All right, good morning, ladies and gentlemen, and welcome to the second day of this technical enablement. So yesterday we've covered quite a lot of ground. We've covered about 130 slides of the technical presentation, covering everything from implementation, deployment, and the rest of it. Today we are going to have much less presentation and much more labs that needs to be done. So it puts you in the driver's seat, gives you the opportunity to work harder and more on the solution itself, gaining more experience in and better understanding of the solution overall. So in this case, it looks like the majority share of the attendees have joined us today. So good morning and welcome to all of you. Now, ladies and gentlemen, just as a quick recap, once again, as I've mentioned, we talked about the introduction. We explained the solution. We explained how it acts and reacts. We've talked about the pre-deployment that you need to be aware of. We've talked about the KATA platform deployment itself. This is for a distributed mode, in a cluster mode, or even in a standalone mode. Now, next up is talking about integrating your KATA operation, connecting your traffic sources from a networking perspective, and then also divulging into the EDR operations. Right. So, ladies and gentlemen, without any further delay, let's get started. So I do want to give you as much time as possible to work on the labs. The labs are only available during the training phase. Unfortunately, after the training ends, the labs also end. So this means that I cannot, unfortunately, give you any additional time to work on these, right? But with that being said, ladies and gentlemen, the very first and probably the most important aspect of KATA, which is the networking segment, is going to be span traffic. This is raw traffic from the network that can be ingested into the KATA platform through a variety of different methods. So as we have today, your core network switches are responsible for the transactions that take place from all of the devices that's found in your infrastructure inside of the environment. So this is communication, on the internal network. It's also communication into and out of the internet itself, right? Now, we have with the KATA platform a multitude of different integration options, be it span, which is typical local network traffic that can be sent through or duplicated traffic into the central node or sensor. It can be RSpan, it can be ERSpan, or it can actually be a TAP device, so a TAP device, if that's something that you need to go ahead and do. Now, generally speaking, without the core or the raw network traffic that takes place inside of the network, the KATA platform really underperforms in its detection capability, right? This plays a fundamental role as part of the ingestion of the entire organization to give you some good insight into what's going on inside of your network. This is fundamental, as I've just mentioned, right? Now, ladies and gentlemen, when we have a look at the interface itself for capturing span traffic, there's obviously, from a deployment perspective, you need to take that into account, because if you're using your central node as your primary sensor and server, it's essential to understand that, okay, we have, for example, two network interface cards that's going to function from a central node perspective. The first network interface card is responsible for management and maintenance and these kinds of things, and integration, of course, into the rest of the platform. Then we've got a secondary network interface card, and from a central node or a sensor perspective, this network interface card is going to be used primarily for the purpose of going and receiving that duplication of network traffic that your core network switches will typically receive, right? But we first need to go ahead and we need to provision that as a prerequisite. And then secondly, we need to go and configure it so that we can receive that traffic coming in to the platform, right? So as you can see over here in our configuration, be it from the sensor side, the sensor is in the next slide, which I will explain to you how to configure. But what you also need to be aware of is from your capturing ports. The address itself is never configured, right? A span port, a capturing port is not necessary to be configured. You just need to mark it as a capturing device, a capturing port, and then that should be pretty much all. Because generally speaking, if you're working in a local network, it is going to be hardlined to the core network switch, and the primary configuration that needs to take place is going to be on that switch itself, right? Now, if we talk about the sensor itself, we need to go and configure our network interface cards accordingly. And because the networks or the sensor itself does not have a web console, it's essential to go and either log in via SSH or the local command line interface so that we can go ahead and, of course, configure the span capturing that's taking place, right? Now, when we have configured that, ideally what we would like to see is if we've logged on into the central node as our local administrator, we want to see some traffic coming in, right? Some process objects or some network traffic that's coming in as part of the local administrator. Now, as I've mentioned to you yesterday, we've got more than one account that is going to be used as part of this entire operation. The first account is going to be your local administrator account, which is the administration, integration, and configuration of the KATA platform. The second account is going to be our senior security officer, which we have yet to talk about. Now, network traffic ingestion is only one part of all of the options of ingestion that we need to consider. The second part of this is going to also be ICAP integration. So ICAP integration is usually going to be with the help of a third-party proxy, right? If you've got a third-party proxy running, or if you've got the Kaspersky network traffic security that's going to be set up, or the Kaspersky web traffic security platform. In this case, you know, either or options are perfectly fine. We're going to use those proxies and those options to also ingest additional traffic into the platform. So for example, if you've got a third-party proxy system, we need to ensure that SSL bumping is taking place, right? Because the majority share of the internet at this point in time of the conversation is HTTPS, which means that's port 443. This is considered encrypted traffic, right? So without SSL bumping, your proxy will be unable to show us the true nature of communication, the true nature of connection that's taking place at that point in time. So it is essential so that we can get then the right data coming into the KATA platform so that we can ensure that we have full visibility in whatever network traffic is taking place. Now, this network traffic obviously refers to web browsing and web activity, right? Now, when we talk about the central node itself, we need to enable the ICAP server in the central node settings. So this is to enable it, and then we need to go and configure our third-party proxy to be able to send that traffic using the host's address. Now, the host address on this central node is going to be displayed, as you can see over there, as a host, meaning ICAP, and then it's got the RESP mod. And we need to go and configure our proxy to actually send or forward along that traffic to this particular ICAP protocol so that we have the ability to intercept that traffic. This is on the central node. On the sensor, it's going to look very similar, but obviously without a web console. But we need to go ahead and we need to go and enable that if you want to have this network capture taking place from your sensor server. Okay. Now, if we have a look at extracting the user data from the ICAP protocol, we can modify what information it is that we want to find and identify as part of our ingestion, right? So for example, adding things like the client IP, client port, authenticated user, this is going to help us to provide better insight to the KATA platform to overall understand what the traffic is, who it is coming from, and so on and so forth, right? So we need to be able to then to go and have a look at that data as part of whatever connection is being established at that point in time. Now, apart from spam traffic, probably the second most important thing that any organization can do when it comes to data capturing or data ingestion is email. Now, the ingestion of email, because email is still considered one of the primary methods of attack, primary methods of spreading infiltration, it is essential for us to be able to understand what email traffic is coming in. Now, there's a variety of different options available to be able to integrate your email platforms. Our best option in this case is going to be KSMG or KLMS. This is Kaspersky Secure Mail Gateway or Kaspersky Linux Mail Security, because it allows us not only the capability of ingesting the decrypted format of email, but also responding to email. So enhancing the email platforms that you have, be it KSMG or KLMS, and enhancing the information used on these mailing platforms to decide if something should be blocked or allowed with the help of the KATA platform. Now, if you do not have this, the second best option to go for is obviously SMTP integration. Now, SMTP integration is pretty much true for any business that we have out there, right? What it's going to do is it's not going to allow us to do blocking, but what it is going to allow us to do is to receive an unencrypted form of email so that we at least have all of the necessary insight to be able to provide with incident information, alert details, and so on and so forth. Okay, so SMTP integration is then going to be our second option. And third option, which is not very popular, as you can see also actually mentioned here, in corporate organizations at this moment, POP3 is not really a very commonly used format for mail delivery. But nonetheless, POP3 is also an option here. So what we will generally speaking go ahead and do is we will create a BCC mailbox, which means that we will receive every incoming and outgoing email for the entire organization. This allows us the ability to understand what is the emails coming, where the emails are coming from, what it contains, and the same from a sending perspective. Now, your last resort, and ladies and gentlemen, I cannot stress enough how inadequate this is. SMTP from SPAN. It is an option. It's a last resort, but SMTP from SPAN is a very, let's say, lackluster method of integrating your email traffic into the platform. Even though it may be very simple, it is not going to be the best or the most ideal scenario for you ingesting mail traffic. Not only are we not going to be able to see the encrypted traffic, we will not be able to guarantee the delivery. Now, spam traffic in general, if you look at the network hierarchy, is considered the lowest level, meaning that it will result into broken communication. It will result into a broken format of data that's being received, incomplete data that's being received. So as you can obviously see with email, that's kind of very important. So SMTP from SPAN is truly not an opportune method, and I wouldn't even consider it for a corporate organization, right? Now, if we talk about the mail traffic scanning for POP3 integration, as you can see, what we're basically doing here is our sensor. This can either be your central node or a sensor that's deployed as part of the KATA platform, will be acting as an email client, right? And we are going to configure the email system so that it copies messages to be scanned to that mailbox designated with the central node for the organization's mail domain. So we can also then opt out for sending delivery notifications for this mailbox, obviously, because it's going to pretty much be pointless, right? Now we need to go ahead and we need to go and configure this as part of our central node or our sensor server in this case. So we just need to make sure that we've got an account that is specified on the mail system, whatever mail system that may be. We've got the mail server details, ports, and all of those information available so that we can ingest that network traffic, right? Now you can either do this as part of the central nodes configuration, or you can go ahead and you can do this as part of the sensors configuration. When we talk about SMTP traffic, instead of the sensor acting as a mail client, our sensor is now going to act as a mail server, right? And what we're going to do is we're going to configure the mail system to, once again, copy all of the messages to the fictitious domain, and we're going to route all messages to this domain via the sensor's address, right? So it's basically like a shadow domain that will be generated for the purpose of receiving duplications of email traffic, right? Now to configure this, it's very similar. We are going to just go ahead and configure this as a mail server, and we just do that as part of the SMTP integration itself, either on the central node or on the sensor. We can go and we can, limit things like the extracted objects. For example, we do not want to have extracted objects larger than 100 megs be scanned and analyzed by the KATA platform or the KATA sandbox. So you can limit this even further depending on your settings that you have at the moment for your mail server. Generally speaking, mail servers will never, by default at least, allow emails being sent with attachments over 100 megabytes, because that's just an unnecessary usage of the system, in my personal opinion. But you have the ability to go ahead and modify this and align it or synchronize it with whatever it is that you have in your mail service, right? You can also go ahead and you can disable protocol passing in raw traffic. So basically, when we talk about protocol passing, is taking whatever information we have, putting it or passing it into a smaller package, and sometimes this could lead to loss of data. And by loss of data, please take it as with a pinch of salt, if that makes sense, because what we are losing out on is true origin details. True origin details can actually be a major factor when it comes to the data that's actually being presented or being ingested into the platform as a whole. So that's the span traffic side. Span traffic configuration is very simple on the KATA platform, as you can see. It's very simple on the sensor, as you can see. The primary configuration is being done on your core network switch or your TAP device, right? The same goes for your email. We just need to enable it. We need to go ahead and just configure the integration, and that's pretty much it. But nonetheless, do you guys have any questions regarding those ingestion methods? Please, now is the right time to ask those questions. Thank you. All right, so I don't see any questions at this time, ladies and gentlemen. So let's move on then to the primary, let's say, essence of today's session, which is the KATA detection technologies. So, ladies and gentlemen, when we talk about KATA, we talk about our network traffic analysis capability. We're talking about the networking side of the discussion, right? KATA EDR is split up into networking side and endpoint side, right? So from a KATA side, there are a couple of things that we need to go have and look at. So for example, some of the core technologies as part of its detection technology is going to be things like IDS. Now, IDS, or intrusion detection, is going to allow us to detect a variety of different network attacks. And this is going to be detected using the span data, as well as the user updatable rules. And this is based on KATA. Now, KATA is effectively going to allow us the ability, and with that being said, the IDS is going to allow us to detect a variety of different things in the network itself. So even from traffic relating to advanced persistent threat activity, just based on its communication patterns, based on its source and destination communication, we'll be able to identify things like botnets. We'll be able to identify a variety of different things in this particular area. So then the secondary thing here is going to be URL reputation. URL reputation, once again, is going to be directly linked into IDS as well as, in general, the network communication when we talk about URLs. And this is going to be detecting things like dangerous, phishing, and APT-related links or URLs. So obviously, globally, we've got a variety of different URLs, IP addresses, domains, and these kinds of things that's listed as part of, activity relating to malicious activity, be it phishing attacks, be it relating to APT attacks, be it related to some form of malicious activity that's being taken place. But nonetheless, the URL reputation is going to help us to understand any form of communication from your internal network to some of those URLs, which could indicate communication to a command and control server or any other forms of already existing infiltration and inspection. But nonetheless, you also have the anti-malware engine. Now, something that is quite interesting about the KATA platform, which generally speaking is only included in things like endpoint security solutions, is that it includes the anti-malware engine. Now, the anti-malware engine helps us significantly in its overall capability to have a high success rate when detecting malicious activity. And this can come based off of whatever source of ingestion of data. So, for example, the data that is coming in via email, data that is being picked up by the span traffic, right, from the network itself, or from your proxies. All of this information will first go and validate and verify its reputation based on its signature. You also have the anti-malware engine, which is heuristic based, and it's got the behavior activity that is also as part of it, right? Understanding the activity better to be able to provide us with a significant increase in the overall detection. Something that perhaps your endpoint security solution may not even pick up on, the KATA platform will be able to do that. Right. Then we've got the mobile attack analyzer. The mobile attack analyzer, as the name suggests, is designated specifically for mobile networks, mobile traffic. And for those of you that actually follows any threat-related news and threat-related information, Kaspersky actually detected an attack with the help of the mobile attack analyzer in our own organization, right? And this was using iPhone exploits. Not too long ago. If you want to look that up, you can search for Operation Triangulation. But nonetheless, yeah, we were able to identify an attack because iPhones limit and restrict cybersecurity companies to embed or integrate into their operating system as part of a defense strategy. We were able to at least detect that activity and threat activity as part of our network. So the mobile attack analyzer truly is a fundamental part for any organization that has obviously Wi-Fi access points or anything like this for business users to have communication over their mobile phones. Then you have the sandbox, and as part of the sandbox, this is an on-premises based sandbox that gives us an opportunity to directly integrate into the KATA platform. So for example, the automatic submission of files, executables, URLs, and these kinds of things will then of course be shared into the Kaspersky sandbox, either automatically or manually or both, by the user or the administrator or the security analyst. So that gives us an opportunity to detonate or execute. We use that as a synonym in the term of sandbox. Those particular files or executable files or links in a segregated, secured environment on sandboxed devices to truly understand the true nature of particular files, and these kinds of things. Right. So with regards to the sandbox itself, the sandbox has a variety of different operating systems, as we've discussed yesterday, and it also, with the latest version, gives our customers the opportunity to add their custom operating systems with custom third-party software as part of the entire operation. Right. Now, when we talk about Yarrow rules is very similar to indicator of compromise or IOCs, but this is a much more precise measure, precise detection and rule generation. Now, obviously, Kaspersky has a whole list of different Yarrow rules that we can supply to our customers, but generally speaking, it also gives an opportunity for third parties and even our customers themselves to generate and create their own Yarrow rules to ingest into the system as part of the scanning technology. Right. So there are some of these technologies that is updatable, and some of them is going to be considered, as part of a customized option that's available, right? So we'll talk about them as we progress through. But what's very important to understand is the inner workings of this entire operation. So for example, when we talk about IDS or sources of third-party IDS rules, I've mentioned to you that it is based on KATA, and from there we get information from our own experts, our own expertise, from other vendors, from open sources, and this is all to identify a variety of different attack methods as part of more advanced or more complex or more targeted attacks coming into a potential organization. So these third-party IDS rules, you can bring in your own as well. You can create your own as well. You can import them from third parties as well. This is a completely updatable logic, which means that not only will you utilize that of which Kaspersky supplies, but also whatever you want to bring into the conversation as well. So the same goes for Yarrow rules, for example. What you're seeing in the background here is actually the threat intelligence portal of Kaspersky. Now, the threat intelligence portal is a paid subscription for our customers. This means that when you go to APT reporting and our threat reporting details, you'll be able to download things like the master Yarrow rules and the master IOC files. So these are the most up-to-date, most comprehensive, most conclusive data that you will be able to get relating to advanced persistent threats, based on Kaspersky's own expertise and own investigations. So this information you can download and you can import into your KATA platform locally if you'd like to. But it's important to understand that you can obviously import, information from a third party as well. Now, if you have a look at the bottom right here, you can see that this is a very, very basic, very standard Yarrow rule. Now, if you're not entirely sure what a Yarrow rule is, I'd highly recommend to have a look at some of the videos that Kaspersky has on YouTube about Yarrow rules and about what it is, what it contains, what is the potential of it. But generally speaking, this is a much more comprehensive method of additional detection options and opportunities for organizations, right? So with that being said, as part of any security solution, there's also the possibility of adding exclusions, right? So if there's something that's popping up in a large amount of objects as part of the platform, and you consider that to be fine or normal operating procedures, or whatever the case is, you can go ahead and you can create things like exclusions. So for example, if it's a particular file or a particular executable, you can see here that we can go ahead and we can add its signature. So MD5, for example, and we can go and we can say that this is something that we should exclude from our alerts, exclude from our incidents that's being generated as part of the platform. All right. Any questions up until this point, ladies and gentlemen? All right, so I don't see any questions at this time. So ladies and gentlemen, I've been talking about this since yesterday, and I mentioned to you that you've got separate dashboards, different dashboards on the central node itself. When you log in as a local administrator, you will obviously have the capability of integrating solution, configuring it, doing all of those different administrative tasks. But then you also have an analyst's dashboard. Now, the analyst dashboard is actually the true purpose of the solution, right? Because the analyst's account, be it a senior security officer or a security officer, this is where they will go and identify things like alerts, where they will identify things like incidents. This is where prevention or response activity can take place. This is where custom rules will be brought in. Any task that needs to be issued into a particular device that contains some form of, let's say, malicious activity that needs to have a response activity, then in that case, this is where all of that is being done. This is where threat hunting is being done. And this is where your variety of different security analysts inside of the organization will be able to create and identify and work on incidents that's generated by the platform so that you can have that proper security taking place. Right. Now, on this dashboard, obviously, each user will have their own dashboard so that they can manipulate and modify it so that they have a look at what they would consider the primary, the most important details as part of the solutions detections, right? Now, when you look at the alert section, for example, this is where you will find all of the alerts that's generated by the system so that you have better insight of what is going on inside of your organization. Now, what I want you to focus on firstly is the technologies. So the technologies area is going to tell us which technology has detected a specific alert, right? Here you can see AM, IDS, SB, AM, and SB, right? Now what this means is anti-malware engine, intrusion detection, sandbox, right? So this information is going to help us to understand perhaps the method of detection, which implicitly is also going to mean a level of severity, right? Now, obviously, it does have a severity notifier as well, and you can see that based on its color identification, right? Either gray, yellow, or red, for example. This will tell us, what is something that we need to look at from a security analyst's perspective. From here, we can open up any one of these alerts to identify more details. And depending on the detection technology, it will look slightly different. So IDS detections will look one way, where anti-malware will look another way. Sandbox will look completely different, for example. So depending on the kind of detection that is made and where that data source is coming from, and the data source that I'm referring to is what traffic we've identified it in. So for example, here we've got the data source span sensor. It's going to provide us either with more or less information, but the core message is still going to be relevant. Now, based on this information, you will obviously receive, if it's something like an IDS detection or an anti-malware engine detection. So here you can see this is what the anti-malware engine has identified it as, ICAR test file. You can click on that and you can find out more information. But for any kind of detection that's coming in, we've got the opportunity to find any related data, either related to the email address, the IP address, the host name, the file, or that specific time frame, all of which we can find underneath similar alerts or similar events, right? From here, we can already take specific actions, such as creating prevention rules, for example. We can do further investigation to find more information on our threat intelligence portal. We can download it and we can identify, further details about it if necessary, right? And once again, as I've mentioned to you, depending on the detection technology and depending on where the data is coming from, the more or less information is going to be presented. So this is an IDS rule. This is a custom IDS rule that was added to the IDS detection list. So this is something that I created myself. You can see that I've marked it as a low importance level. The data itself came through the span sensor itself, but still we will be able to do things like downloading the IDS artifacts, downloading PCAP files, finding related information, related hosts, and so on and so forth. Okay. When we talk about an URL reputation alert, the URL reputation is going to give us insight surrounding if something is considered, command and control server related, or is it just considered a malicious host, a malicious file, malicious link. All of this is going to help us to understand things like who was it, where was it going, or where was it coming from. It's going to tell us the link, the URL itself, so that we understand that a little bit better. Now, what you'll notice here, and you'll see this in a couple of slides as well, but I want to point this out to you already. At the bottom, you can see the change log, and you can also see assigned to analyst or state in process or whatever the case is. Now, with this information, if I have more than one security analyst, I can add my comments to this as well. For example, I can add a comment to say that I've investigated this, this is a test, right? And I will add that comment and I will close the alert here up top. If there is something that I need to verify or clarify with a specific analyst that's maybe specialized in this, I can add the change log and then I can assign it to that particular analyst in the system, right? So for example, I will then move this alert through to another individual in my team that is perhaps a little bit more capable of understanding this particular details because they specialize in it, right? So this is for your URL reputation detections. The mail-related URL reputation alerts is still URL reputation, but you will notice that this is based off of an email because in that email, there was a link that was added to the body of the email, and you can see that it's this exact same URL. So it's a different, let's say, ingestion method. We can see different information such as a sender email and recipient email information. We can see the header files of the email itself, but primarily it's still considered a URL reputation, right? Because email is just another form of ingestion traffic. Okay. If we look at web traffic, so detection of dangerous files in web traffic, this is not a dangerous URL, but rather a dangerous file. In this case, we can see that our data source was the ICAP sensor, meaning our proxy, right? And we've identified that the file itself in question is going to be, once again, the ICAR test file, for example, over here. And we can see, okay, this is a dangerous file that was found as part of our alerts. If we detect the same kind of thing on email, you will notice that the data source is no longer ICAP. That's quite obvious, I guess, but rather our SMTP sensor, because we used SMTP integration. With that being said, we will then be able to identify, once again, sender and recipient details, header files, subject of the email. We can even go ahead and download that particular email itself for further analysis if required. Now, if you wanted to get any additional information about any artifacts or any information on detections, we can go and we can have a look at our threat intelligence portal. Now, with the purchase of Kaspersky EDR Expert or KATA or both, you will get an allocation for free to our paid subscription-based threat intelligence portal to do things like threat lookups. Threat lookups on the threat intelligence portal, which is shown on this particular side of the screenshot, can be used to understand the threat a little bit better. We can understand anything that Kaspersky has on related IP addresses, URLs, if it's related to advanced persistent threat activity, how many times it's been used, and so on and so forth. Right. All of this information will help us to understand the threat a little bit better, so that we can make a better decision of how to proceed moving forward. Okay, so those are the primary things when we talk about the KATA technologies itself from a detection perspective, obviously focusing in on the networking side. Next up, we'll talk about the EDR side and its detection technologies, but first, let me give you an opportunity to ask any questions if you have. Okay, so next up is going to be the EDR capabilities, because remember, this is a platform that involves both the networking side and the endpoint side. So now we're moving over to the endpoint side. Now on the endpoint side, our EDR is going to provide us with a couple of different additions to this. For example, the TAA, which is the Targeted Attack Analyzer. Now, the Targeted Attack Analyzer helps us to identify and detect things that's known as IOAs, or indicators of attack. Now, indicators of attack are basically going to be a full list that's compiled by things like the MITRE ATT&CK matrix to identify a variety of different attack methods, methodologies, techniques, and procedures that is typically, or that has been historically used by cyber criminals to infiltrate systems. So activities such as, for example, using PowerShell or navigating a background PowerShell script as part of a Word document, this will be flagged, for example, or multiple, let's say, attempts that failed attempts at username and password combinations for a device during logon for Windows. This will also be flagged because that's considered a brute force attack, right? So these are just two very, very straightforward, simple examples, but the targeted attack analyzer gives us the opportunity to truly understand all of the additional telemetry that's coming from our endpoints, to really be able to see, what is the activity? How does this relate to network activity? And we will be able to generate alerts based off of this info, right? The sandbox itself, the sandbox will obviously also be used on the networking side of KATA, but from a EDR perspective, the sandbox can also be used to basically submit automatically files and executable files and these kinds of things to the sandbox for further or additional analysis and confirmation of its verdict. But the administrator with EDR during a threat hunt or during even creation of a separate custom task will have the capability of basically submitting files manually to the KATA sandbox for further analysis. So basically taking something that maybe the system didn't automatically submit, but you consider it suspicious and you want to have final confirmation, you as an administrator will then be able to submit that into the sandbox using EDR, and it will provide us with a detailed verdict. All right. IOCs, or indicators of compromise, and Yara rules is very similar to one another, but IOCs is considered indicators of compromise. Now, an indicator of a compromise means that this is post-breach, right? So post-infection. This means that I already know what I'm looking for, and I basically now need to identify if any of my other devices also show symptoms or indicators that they have been breached or compromised, right? So that is what an indicator of compromise is. So, for example, I know that this file or this registry key is related directly to some malicious activity that we've seen in the environment. Now I just need to identify and verify if any other devices in the infrastructure also shows the same signs that show the same symptoms of an infection. Whereas Yara rules, as I've mentioned to you earlier on, it uses the same, let's say, methodology, but it's a lot more comprehensive, giving you an opportunity to create much more intricate, complex, let's say, rules and regulations that can also be used as part of the scanning technology. And finally, of course, also the anti-malware engine. I'm sure that I don't have to go into that too much detail because I guess this is, something that is expected. Okay. Now, with that being said, the EDR technologies are going to be applied primarily automatically, right? With the exception of things like Yara rules and IOCs. You can see that it says on request or on schedule. Basically, what this means is that by default, we do not provide any further custom IOCs or Yara rules as part of the system. Obviously, it has its own built-in, and that's going to be used. But in this case, you need to, or you have the opportunity or the ability to add your own, right? Import your own, create your own, import from third parties, import from third-party vendors, or threat intelligence organizations, or whatever the case is. So indicators of compromise in Yara rules will effectively then be that opportunity to also ingest. Because you're sitting with all of the data, all of the traffic on your KATA platform, it is opportune to be able to use that to do further analysis based on what is actually inside of your environment, right? And you can do this retrospectively as well, which means historically, right? Any historic activity, historic data that's been taking place, that will all then go ahead and be obviously ingested, right? So we can import these third-party targeted attack analyzer rules, which is also your IOA, or indicator of attack rules. Now, these indicator of attack rules is not post-infection, but actually pre-infection, right? Where IOC, or indicator of compromise, is post-infection. IOAs are a little bit earlier in the kill chain itself, because it gives you the opportunity of identifying something that is ongoing, not something that took place historically, right? But generally speaking, you can once again create your own rules, bring in or importing your own rules from third parties, that will be completely based off of the experience and expertise of the team that's actually handling the solution itself. The same goes for IOC rules. As I've mentioned to you, IOCs by itself is going to be empty or blank in the beginning. Kaspersky has our own set, but that's not going to be listed here. These IOC importation capabilities is primarily for any custom ingestions of IOCs. So just to give you some insight of how useful this can be, for example, there's some of the customers that I've dealt with that actually use our, not even this full-fledged KATA platform, but they would use our EDR Optimum platform. And they have an authoritative body in the country from the government that basically on a week-to-week basis provides them with a full list of IOCs that they have noticed from a government level that's targeting either the specific country or specific industry that they're working in. So they basically import the new list every week and scan their devices accordingly. And this helps them to understand or identify if there's any dormant forms of infection that hasn't become pronounced just yet inside of their own infrastructure, right? Giving them that opportunity, right? So the IOC scanning technology as part of the KATA platform is going to be handled directly by EDR, right? With that being said, you have two modes of configuring these IOC scans. You can either do so as part of the Kaspersky Security Center, which gives you much more flexibility in scheduling, much more flexibility in the scope of devices that needs to be analyzed and scanned. But as part of the KATA central node, you will only have the one option, which is going to be a scheduled scan that's taking place on a day-to-day basis at a specific time, right? Now, as you can see, it's a little bit more limited on the central node itself, hence why I'm suggesting to also look at the Kaspersky Security Center to give you a little bit more flexibility when we talk about indicator of compromise scanning, right? Now, we are almost coming to an end of our presentation side, right? And like I said, we're not going to present as much today. We want to give you an opportunity to work with the solution a little bit longer and a little bit more, right? Because we do understand that obviously it's a little bit more complex than conventional endpoint security. So we want to give you that opportunity. But before we go ahead and do that, let's quickly finish up the last couple of slides. So next up is the targeted attack analyzer and its alerts. As I've mentioned to you, the targeted attack analyzer results into indicator of attack alerts, or IOA alerts, right? Now, this can be anything and everything that could be perceived as either malicious or suspicious based on the activity or the way that it works and operates. So for example, using Microsoft exec to install a package from a particular URL, right? Not just from a local file, but specifically from a URL. This is something that, number one, has came in via the data source of an endpoint, right? Because this is an EDR capability. With that being said, we can then click on that to identify more information. We can scroll down and we can see, okay, this is another IOA alert. And over here, we can see that based on this IOA alert, perhaps it's linking into a sandbox alert, such as in this scenario here. So here we have a sandbox alert, and the sandbox itself will provide us with much clearer picture. As you will see in the coming slides tomorrow, it will provide us with a much clearer picture of what is exactly going on, right? But generally speaking, we can see that this particular TAA rule, which is change Windows firewall port that we added, that has triggered the detection itself. But from there, based on that detection, we also then put the same details that happened on the device into our sandbox, and then that resulted into, here we can see IDS, so the IDS system was also used. You can see a good collaboration of a variety of different technologies. And you can see that this is relating to a command and control server. Okay. Now, when we talk about IOCs, just to bring you back a little bit, indicator of compromise obviously means that something has already taken place and we searching post-infection. But you can use IOCs in a pre-infection state as well, just to have a little bit more of a proactive approach. Obviously, I'm just using this to differentiate between IOA and IOC for this context. But generally speaking, IOCs can be used at pre or post-infection, either proactively or reactively, basically, right? But generally speaking, when you do an IOC scan inside of your KATA platform, it will then result into something like this. So if there's a positive identification of some of these indicators that we would consider to be compromised, then in that case, you will receive an alert. Based on this alert, we will then be able to see the exact area as part of the IOC rule that resulted in a positive identification. So here you can see on the right-hand side, this is what the plain text IOC rule would look like, right? Because we use the globally recognized standard for IOC creation, which is open IOC format. It means that we can integrate much more into other vendors and their let's say IOCs, give our customers the highest percentage of integration options. But based on this detection, we can see that it's highlighted as per the initial red, and I'll remove mine. And here you can see it's highlighted in yellow, right? Showing you the exact area as part of the IOC that was detected. So in this case, it was for a file, and this was based on an MD5, which is the signature or the hash of that particular file. And this was found on this particular device. In this case, it's for Alex desktop, right? Okay, so this is what it would look like if we have an IOC detection. Okay, so at this point, this will be our last slide for the presentation today. I mentioned this to you already. We're not going to waste any time. We're going to finish up with the presentation so that you guys can continue on with your labs, right? But nonetheless, when we talk about a targeted attack analyzer alert, you know this one that we saw earlier on. If you click on that, you will actually find more details about it. So a detailed description of what's going on. You will see a recommendation, the possibility of a false positive, yes or no, and a little bit more context. And then you will also see the techniques that is used as part of this indicator of attack detection. So here we can see the micro attack techniques. So each one of these techniques has their own independent code. So T1071, for example, here, T1105, T1218.007. So each one of them is either defense, evasion, command and control, command and control. So it will give you a brief explanation directly in the alert, but you can also go ahead and you can click on it to understand which advanced persistent threat actors has used this in the past, what is their strategy, so that you can potentially look out for future signs that there's some form of breach that could have potentially taken place. Okay, so a targeted attack or the targeted attack analyzer or indicator of attack detections will obviously show you a significant amount of alerts based on your configuration. It is advisable though that as soon as you deploy the solution in your environment or your customer's environment, to note down these detections. You have an initial investigation and understand what is truly happening. And then you need to understand that for any complicated system such as this, it's necessary to add some level of exclusion so that we limit the amount of data that's being shared with the security analysts so that we do not have that investigation fatigue. Because this is exactly what the system is designed for, is to reduce the overall fatigue, reduce the amount of time and effort by your analysts to identify even the most complex threats, scanning through all of the, let's say, common attacks and really going into the more unique ones, the more complex ones. And those are typically the ones that cause the most damage to a business, right? So it's necessary to fine tune the system after the initial deployment to really get out of it what it is you want to identify. Okay. So, ladies and gentlemen, do you have any final questions for me regarding anything that I've mentioned today in our presentation? Our short, albeit powerful piece of presentation.